for video 2.13, we're going to be building on the skills that we used yesterday in class to look at how we actually make the equations for those lines that we've been using to make predictions for our scatter plot data. So the first thing you need to know is, what is a least squares line? A least squares line has many names, also the line of best fit or the regression line, and it's the equation that is used as a predictor for data sets. So like we were doing before with the height and the men's shoe size, it is a way for us to say what the predicted value of the next data point might be. The name the least squares line comes from the line that has the smallest sum of squared residuals from a data set. So we've done residuals yesterday. Now we're going to square those square those residuals and add them all up in a process that's kind of like when we found standard deviation. So the most common choice for the best line is the line that makes the sum of the squared residuals as small as possible. So what we need to do is add a column over here that is going to be our squared residuals. Now this table comes right from the work that we did yesterday in class with the shoe length and height of men. So I'm just going to go ahead and square all of these values, and then I'm going to add them all up for a total at the bottom. So I've gone ahead and squared all of our residuals, and we have 6.6564, 12.1801, 1.1025, 0.5776, 0.9025, 0.9604, 4.6225, 0.9025, 0.3364, 6.3301, and that all adds up to 34.54. So let's take that and answer these questions to interpret why we did this. So why do we use the sum of the squared residuals instead of just the sum of the residuals without squaring? Well, if we were to add all these residuals up, because of the positive and negative values, it would only add up to 0.6. And that really doesn't tell us anything about the size of our data spread. Just like in standard deviation, when we had to square them to make them all positive, we have to do the same thing with the residuals, because the negative and positive values cancel each other out and don't give us an accurate representation of what the data really is. So that would go here in this space. And what is the sum of the squared residuals for the line y equals 25.3 plus 3.66x and the data of the table above? Well, this line is the equation for this set of data, the line of best fit or the regression line, and we already summed all of it up right here. So just make sure you know that when you go into class tomorrow, you're going to have to square the residuals and add them all up in a table, much like we did here. Now, the regression line equation comes from a very long process of calculations and very complex and specific calculations that you would have to do to find out what your equation is. So we're going to go ahead and do it on the calculator. Now I know a lot of you don't have calculators at home, so all I want you to do is write down the steps here for finding the regression line on the calculator, and we're going to do it in class tomorrow together, so you can go ahead and enter data in and find the regression line automatically instead of having to calculate it. For your hot question, I want you to answer this question. We answered it on the third slide of this video. Why do we use the sum of the squared residuals instead of just the sum of the residuals without squaring? I explained the answer to that after we filled out the table with the squared residuals. Please put it in your own words, put it in your hot question, and we'll work on the scale tomorrow in class.